Hello students, in the last video we have seen the classification of secondary storage devices. In this video we'll see in details some of these devices. So first one we'll take up the magnetic tape. So if you have seen a music tape, it looks similar to this magnetic tape. So it is a plastic tape with the magnetic coating on it. Data is stored in the form of tiny segments of magnetized and demagnetized portions on the surface of the material. The magnetized portion of the tape refers to bit value 1 and demagnetized portion refers to 0. So when I say these things, you might be wondering what this looks like. So you might have seen the music cassettes, the ones that we used to put into a tape recorder and we used to play it. A magnetic tape resembles the same tool or the same way a music cassette is. So these are available in various sizes, and when the difference between these sizes include the speed, okay, that is how fast the read and write is done to the tape, and the amount of data, that is in terms of binary digits, that can be stored in this tape. And the tape is very durable, it can be erased and reused. You might have seen some of the blank cassettes, it can be compared to that one. So blank cassettes which we used to record songs and again delete it, and if we wanted we could rewrite it again. And it's inexpensive and it's reliable if you keep it properly, like if you store it in the proper place, then it is very reliable for organizing archives medium and taking backups. But the thing is, this is not suitable for all kinds of data. For example, if you have data that are often updated, so this method is not the one that is suggested. And if the tape stretches too much, so that is after using it so many times, what happens, it is not usable to store the data. So when this happens, the data you are trying to store in this may be lost. So today it is only used for backing up or duplicating the data on the hard disk. If in case the system corrupts or there are power failures and you lose the data, so only in that cases or as a backup this magnetic tapes are used. So this is how a magnetic tape looks like. So how the information is stored? Usually the tape is divided into 7 or 9 tracks. So these 7 to 9 tracks has information in it, and the tracks which are followed or which are overlapped by the frames, okay, all these things form like a column. So wherever the bits are present as 1, you can see it is counted. For example, in the first row it has 3 ones, that is odd. So in the first column it is 7 and again the number is odd. So based on this the parity bit is added, like how many number of ones are there. For example, in the first row it is 7, that is an odd number, then the parity bit will be 1. In the second column, if you see, the parity bit is 2, and same way you can put how many parity bits are there present in the last row, that is P. So if at all there is a mismatch between the number of ones found on the columns or the cells and the parity bit mentioned in the last track, then the whole sequence is tested again and reported that whatever the information is written or is got by this tape is not accurate, it's wrong. So in this way we can come to know if the information stored in this is you can trust this information or not. So it is divided into small vertical columns called frames and horizontal rows called tracks or channels. So it has one character per frame and each frame spans multiple tracks, as you have seen in the diagram. So only one bit can be stored per frame, and the remaining store at the end will be storing the parity bit. So when a byte is returned to the tape, the number of ones in the byte is counted, and the parity bit is then used to make the number of ones is even or odd. So again, when it is read, that is what I said, when it is read by the system, then they check the parity bit to the number of bit present there in the frames, and if there is a mismatch, then we can say that some of the bit is lost. So it has two reels, that is supply reel and take up reel, which are mounted to a hub, and tape moves from supply reel to take up reel. So this tape is coated with the magnetic oxide, and side of the tape passes directly over the read or write head assembly, thus making contacts with the head. So when the tape comes in contact with the head, it means that the information on the tape can be read. So this is how physically it looks like. That is, as the tape passes directly under read or write head, the data can either be read or transferred to the primary memory, or read from the primary memory and written onto the tape. So this is how physically it looks like, but the block diagram you can represent it this way. See, as we spoke about the supply reel and the take up reel. So supply reel is the one that actually supplies the reel for the read or write head assembly. Okay, and when it passes through the head, it is read. Whatever the information is there on this magnetic tape, it is read. And once the information is read, then the reel is passed to the take up reel. So this happens, and you can see this picture is resembling a music cassette that we used once a long time back. So this is the basic tape drive mechanism. Now, how the information is contained in these tapes? See, you might have seen the music tapes. There is a blank in the first few length of the tape, and even at the end of the tape there is a few blank, and in between this there is a magnetic oxide which is a little dark in color, and this empty space at the start and then you can see it as a transparent or a white tape. It's just a tape, and it does not have any magnetic coat on it. So that represents the start or beginning of the tape, that is BOT. And there is an interblock gap, that is before starting some information that is written on the tape to be read. So it has to be a gap so that we can get to know that there is a record in the next coming positions. And if some of the records are read, and after that again there will be interblock gap, so that you are actually reading the next record. So this goes on until the end of the tape. But inside again the record space what we have, it is again divided into inter record gap, that is in between the records also there are some gap, and that is IRG we call it as. And in between these IRG we have the actual information that the tape is containing. So this is the information format of a magnetic tape. So the starting a white or transparent tape, what I said, it is a physical marking to indicate the location from where the tape should start reading. And the length between the BOT and EOT, it is actually the one that is used for recording. And in some there are sensed arrangements of lamps such like photodiode sensors to indicate the location from where read or write should start. In magnetic tapes, data are stored in terms of blocks, where each block consists of a grouping data known as records, and in between these records we have something called as a interblock gap, and This has some of the records in between them, and inside one interblock gap there are few inter-record gap and the record that we need to read or write. So whenever an IRG is this, the moving tape is stopped until the record is processed. That is, whatever the information that space contains is processed by the system, and when the process is finished, again it is the reel is allowed to move. So if we are speaking so much about this magnetic tapes, then there has to be an advantage, right? So there are so many advantages of using this magnetic tapes. That is, it has a high recording density, that is low cost per bit. To store one bit, it is very easy. Okay, and the tapes can store so many amount of data in it, and virtually they are unlimited storage capacity. That is, you can have so many cassettes or so many tapes. There is no constraint that after 20 cassettes it will not support, or after one or two cassettes it will not support. No, so unlimited cassettes can be put and read. So virtually there is no limit, but each individual tape, like with the case, has a limit. But otherwise you can use so many of them or so many tapes uh, relatively or accordingly as you need. And you might have seen the music tapes or music cassettes, you can just compare to with it. It's portable, it's small in size, and it's lightweight, and it is removable. You can just take it to it places wherever you want and just use it. And it is easy to handle and store. You can store in a dust free and humid free environment. That is all. Nothing special care is needed for that. Then it is very inexpensive, and again it's a offline, so a large amount of data can be stored in a small storage space. So if there are advantages, there has to be a disadvantage also. So that is, it is sequential in nature. You might know, if you want to read the second song, you must go through the first song. At least you need to fast forward it, right? In the music cassette, same way, it's a sequential one, so you cannot just skip any of the records. You just have to do one after the other. And when we compare this to magnetic disc, it is a little slow, and it should be kept in a dust free environment, as I said before, and away from the corrosive gases and chemicals, because they can cause the tape reading errors. And since it uses a parity bit, even if there is a minor error, it is difficult to recover the data, and you will know that data is not perfect, and it's not flexible. That is, you cannot feel record as you feel, but to some extent you can erase and record in the tapes, and they wear out easily. That is, a little more care is needed for the maintenance of these magnetic tapes. So what is a magnetic disc then? It is a high storage capacity and a reliable storage device, and you can access the data directly, as not sequentially as in the magnetic tapes. And it consists of a plastic or metal circular plate platter which is coated with the magnetic oxide layer. Data represented as a magnetized spots, and magnetized spots represent 1, and if it is not magnetized, it is read as 0. To read the data, these magnetized spots on the disk are converted into electrical impulses, which are then transferred to the processor for processing. So writing data onto disk is accomplished by converting the electrical impulses that is received by the processor, and is turned to magnetized spots on the disk. And again, in this disk you can erase and reuse the disk, that is any number of time virtually. And there is a protective case for this, to protect it from dust and other external interference. This is how a magnetic disk looks like. So you can see it is divided into tracks, as well as a cluster, as well as a track sector and a disk sector. Okay, so this is the organization of a disk surface. So remember, These are important diagrams you need to know on the examination point of view as well as knowledge point of view. So you should know how it is, what it is called and how does it work. So as we have seen in the last slide, imaginary tracks and sectors are present in this magnetic disk, and there are concentric circles where data are stored in are numbered from the outmost ring to the innermost ring with the 0, and sectors refer to the number, that is fixed sized areas that can be accessed by one of the disk drive, that is to read or write in one rotation of the disk without the head having to change the position. And the interaction of the track and disk sector is known as a track sector. So it has generally 8 or more disk sectors per track, and it is marked with both the surfaces, hence it is called a double-sided disk. And each sector is assigned a disk address before a disk drive can access a piece of data. So it consists of a sector number, track number, and a surface number. And track sectors are grouped into collection known as clusters. So it is referred to as a minimum amount of disk space used by a single file. So disk, pack, and a cylinder we'll see in the next video. Thank you.